Hello and welcome to the show. Now, latency and lip sync are the subject of today's show, and to avoid any timing errors, we've sent Simon out and about again. Simon, where are you?
Thanks, Matt. So I'm at Hitomi today, and they're the market leaders in lip sync and alignment tools. And with me is Russell. Russell, thank you very much for having us today. Let's, before we get started, give us a bit of background on Hitomi.
Certainly. It's good to have you here, Simon. Thank you for coming to visit us at Rutland Barn. So Hitomi has established itself as a market leader in measuring timing and alignment for live broadcasts, essentially. So anybody who's got a premium sporting event or a news thing or even an entertainment event where it's very important for the value of the content to be proven to be nicely timed up. Everybody notices when lip sync's wrong. It's something that everybody talks about. Even my grandmother notices when the lip sync's wrong. But there are other aspects of timing which need to be measured in live events. So it's not just the audio to video, which is lip sync. Audio to audio timing is important if you're doing things like surround sound, but also video to video alignment. There are times when you need to synchronize your cameras. There are times when you need to synchronize your virtual background to your real background for virtual studios, for example. And there are many other applications where it's important to know how different signals are timed up. And that's what we do. We measure it.
So let's rewind, I guess. Just explain the difference in latency and lip sync. Latency and lip sync in layman's terms.
Okay. Well, lip sync literally is hearing what you see. So it's the alignment of the audio and the video. And human ears are very subjective to it, particularly if the audio is ahead. If you hear something before you see it, it really screws our brains up, because in the real world, we normally hear things after we see it, if it's happened further away, and we can make an adjustment for that. That's not right. But the other way around, it really does mess with our heads. So that's lip sync, AV timing. Latency is the actual time of flight of a signal. So latency can be, if latency of audio and video are exactly the same, then they can have an ideal lip sync, but it can still take a while for a signal to get there. So in the live environment, if you're interviewing somebody who's on another part of the world, there will be some sort of delay in getting the signal from that remote location back to the studio. And so it's important to know the latency in that respect.
And I guess over the last 18 months, particularly where there's been more live content, lip sync particularly has been very noticeable, but latency as well when people are having an interview.
Absolutely, yeah. I'm with so many people being at home. There's some fantastic broadcast tools which have been sent to people's homes. But if they're trying to do a live interview and because of the link that's coming back, it's a second and a half, 2 seconds, you really can't have a two-way conversation.
I guess it extends further than that. I know you've got an example of a car racing event where latency is a big issue.
Yes, indeed. So coverage of live motorsport. Typically on a circuit, you'll have the trackside cameras, which will be wired. They'll be sitting on a tripod, and they'll have a physical cable that goes back to the OB truck or whatever's taking the footage. But for safety reasons, in the pit lane, it's always got to be shoulder-held wireless. And the shoulder-held rigs, they have a transmitter and aerials on them. There's quite heavy compression in order to send it down the link. So it's got to be encoded, and then it's got to be received, decoded. And all of these pipeline delays, they introduce extra time in order to get the signal back. So if you do a straight cut from a low latency camera, which you've got at the side of the track, to a high latency camera sitting in the pit lane, if you haven't made any allowance for it, you'll see the racing car go past the same point twice, which is not very good for the fans. It's, oh, what happened there? So the answer is to measure the latency of your high latency path and make an adjustment so that you can do a clean cut and they've all got the same time delay on the same cameras.
So since I've been here, I've already learned an interesting fact that the speed of sound is 1 millisecond per foot. And you've got a really good demonstration behind us that demonstrates how your tools can measure that as well, haven't you?
Yes, indeed. It's something that I like to do at the NAB show in particular, because the Americans like to talk about the speed in feet. 3 milliseconds a meter, it doesn't sound quite as good as a millisecond a foot. So I can just about stretch out about 3 feet if I move my hand away, and you see the thing change, and people go, oh yes, and then move it back again, and you see it go back to exactly the same place. It really is that accurate. You can use glass almost as a ruler.
Yeah, it's a good visual thing. So we've looked at sports. What other applications are you seeing the products used in?
The news is particularly an application. People would say that the news aren't as fussy about lip sync as the live sports people were, because news happens and then they move on to something else. Whereas sports content, there's a really high expectation of real quality coverage, and people, let's face it, pay a lot of money to have the live feed from some of the world sporting events. But the news is always different, and so you can never be quite sure what timing you're going to get. And for high quality news, you should measure your lip sync as well. So that's quite a good application for it. But live events, we've been used at the Mobile Awards for MTV. And it's something when you've got any type of environment where there is no time to do it twice, you have to measure it and get it right first time.
So, now I think Matt's got a question that he was wanting to ask. Let's
Yes.
go back to Matt.
Thanks, Simon. That's good. So, you've mentioned live events there. Made me think about our own industry events. And we haven't seen you for a while. We haven't seen anyone for a while. But Hitomi, what's coming up in 2022?
So I'm not sure if you heard that, Russell, but Matt was asking what can people look forward to from Hitomi in 2022?
We've got a really new, exciting feature coming out. So we've been able to measure timing on the wire for quite some time. Pardon that expression. But what we've not been able to do is to give an absolute measurement of time of flight. Right. So latency in the truest sense of the word. We've been able to measure latency of a relative path, one signal against another signal. But if you've got a situation where you've got a reporter in the field and all they've got with them is the iPhone, you don't know what the time delay between them answering the question and the guy in the newsroom asking the question. With latency, we can do exactly that. We can give them the time of flight from the phone all the way back to the newsroom.
Wow. And is that something that's available now, or when can people expect to be able to buy that?
It's available at the beginning of the year.
Fantastic. Back to Matt in the studio. Cheers, Matt.
Yeah, absolutely. So, but hold on, that latency feature that you've developed, can you give us an idea of some real life applications?
And another one for Matt. What are the applications of this latency feature that you've developed?
There are several really good ones which engineers will find difficult to do other ways. So if you've got an unknown delay that's going through your broadcast system, let's say an any box delay, there are lots of things that introduce delay. It can be vision mixers, it can be effects units, it can be scalers and decoders and encoders, things like that. If you've got a path and you're not in control of that path, but you just want to know how long the delay is on your bit, we can ingest our generator signal at one end and the analyzer at the other, and it literally measures the time difference between the two.
Okay, cool. Thanks, Russell. It must be really painful for you watching TV sometimes. I know I watch TV and I'm watching it for certain things, but you must have a real painful time.
Yes, my family put up with me saying, oh, the lip sync's out. And now they do it as well.
Thank you, Russell. It's been a pleasure spending time with you. Thanks for having me, and hopefully we'll catch up this year as well.
Great to see you. Thank you very much.
Back to the studio, Matt.
Great. Thanks, Simon and Russell, for that. And do check out the Hitomi solutions at hitomi.tv. They also have some great videos demonstrating exactly how their products measure latency and lip sync alignment. So do check those out as well. Thanks to Mediaproxy for their ongoing support, and thanks to you for watching. We'll see you next time.